This is Sam Asirvadam. I'm one of the cardiac electrophysiologists at Mayo Clinic, Rochester, and discussing a publication from our group on geomagnetic activity relationship with implanted cardiac defibrillators and anti-tachycardia pacing. Dr. Abrile, Konechny, Friedman, DeSimone, and myself, along with other co-investigators, evaluated whether the environment beyond what we experience in our immediate environment can affect how cardiac devices work. There had been some anecdotal reports that during periods of solar storms there were differences in rhythm detection by defibrillators and possibly device function itself. So we thought that we would investigate this at a larger level. We noted a new database that was possible because of an advance in how we monitor cardiac devices called the Latitude database. This is a remote monitoring database that patients have events recorded by their devices transmitted electronically to one large database. Given this unique opportunity, we looked at about 60,000 patients with implanted devices and wanted to see whether geomagnetic activity would increase, decrease, or have no effect on the function of their devices. We had hypothesized possibly during periods of enhanced geomagnetic activity there would be more detections of events by the implanted device. We correlated the recorded events with existing well-accepted scales of geomagnetic activity. This type of activity is essentially closely correlated with solar flares, solar activity, and ejections or coronal mass ejections from the solar landscape. Our findings were somewhat unexpected. We noted a clear correlation that was inverse with less geomagnetic activity being associated with more events that were detected and treated by the cardiac defibrillator. And periods of type 4 or enhanced activity had less events. We don't really know the reason for this inverse correlation, but further study is needed to establish whether possibly the environment, the geomagnetic environment, can affect the genesis of arrhythmia itself, such that when there's more activity, there may be less arrhythmia, and that's the reason there are less detections and treatments by the device. An alternative hypothesis is that this enhanced activity somehow affects the ability of the device to detect the arrhythmia. This is harder to figure out a reason why. Since electrical activity in the heart is associated with an electric and magnetic field, it remains theoretically feasible and possible that external magnetic fields, including geomagnetic fields, can have an effect in the propensity for arrhythmia. We look forward to further investigations both from our group and internationally. Thank you.
We hope you found this presentation from the content of Mayo Clinic Proceedings valuable. Our journal's mission is to promote the best interests of patients by advancing the knowledge and professionalism of the physician community. If you are interested in more information about us, our homepage is www.mayoclinicproceedings.org. There you will find access information for our social media content, such as additional videos on our YouTube channel or journal updates on Facebook. You can also follow us on Twitter. More information about healthcare at Mayo Clinic is available at www.mayoclinic.org. This video content is copyrighted by Mayo Foundation for Medical Education and Research.